Hello. The previous video was about measuring the flatness of the straightedge, and soon there will be a second part completing this work. I am preparing this straightedge and its working surface for the repair of the guideway of a rather large surface grinding machine. There were also videos about this earlier on my channel, videos number 19 and 20. In addition to the straightedge, a support for the autocollimator mirror 1040 mm long is also needed for this repair. This is the virtual model of this support. And this is the virtual model of the straightedge. In reality, I will make them simpler, as there is currently no opportunity to spend much time on their appearance. The priority is functionality and high accuracy. Ideally, it would be better to make them exactly as designed, but circumstances require starting work quickly. So I am agreeing to simplify the peripheral aspects of these tools. The prisms for the mirror stand are being made. After that, I rigidly fixed these prisms on the edges of a square tube with 4 M8 bolts each, with a sturdy common steel gasket and epoxy glue in addition to the tightly clamped bolts. The main operation for creating this support was scraping the prisms into two planes at a 90-degree angle. I was supported in scraping these prisms by a friend whose workshop is equipped with the appropriate equipment. I used his reference plate and his help, resulting in the prisms acquiring the precise shape necessary for using the autocollimator mirror support. I recommend checking out his Instagram page. The address is given in the description. So, the stand and its prisms were made, and the repair project can continue. I have probably mentioned that first. I will repair the largest linear guideway pair on this machine. The length of this pair is 3 meters. A technological feature of this repair is that the straightness will be verified using an autocollimator. Since the mirror stand is already 1040 mm long, I can start the repair without waiting for the straightedge of 1070 mm to be finished. And the first metal shaving will soon be removed with the scraper from these guideway lines. My attention is now focused only on repairing this, the most essential and longest linear guideway pair of this machine. According to my plan, I will ensure the straightness of this linear guideway by using the autocollimator. So, I will control the process of removing excess metal from the guideway using the autocollimator. This device will allow me to scrape the cast iron from the guideway surface only where needed and precisely to the required thickness, no more, no less. Which is crucial in this work. Identifying the areas that need to be processed is the most challenging part of scraping. This condition is quite difficult to fulfill, which is why scraping is considered a complex, highly skilled technological operation. This is why scraping repairs are usually approached with justified caution, primarily because taking truly accurate measurements, when dealing with microns, is far from easy. Making a mistake due to the inability to bring measuring instruments into the correct state or simply being lazy to take measurements multiple times, until all defects of the measuring technology are eliminated and complete repeatability of the result is achieved, is a problem that is very likely and difficult to avoid. Thus, this method using the autocollimator will significantly simplify the repair process. There is no need to dismantle the machine bed is already connected to the foundation and has taken a specific shape, so this problem does not need to be solved either. Moreover, this method allows achieving high accuracy of the Guideway. I will now use the AK-1 autocollimator. Its scale accuracy is 1 arc-second. I also have more sensitive autocollimators, up to 0.2 arc-seconds. But I consider it appropriate to work with the AK-1 in this repair because it will already provide a predictable error of up to 10 microns over these 3 meters. If I use the most sensitive autocollimator AK-0.2, the error would accordingly decrease fivefold, to 2 microns. However, the quality of the measured surfaces is not sufficient for such measurement accuracy. Therefore, the AK-1 will suffice. At the end of aligning the guideways, I will try using the AK-0.2 to see if it provides any advantage. At the same time, the cost of the AK-1 autocollimator is significantly lower than that of the AK-0.2. And since I am working with it in someone else's premises, I have to leave it on the worksite overnight and on weekends, and I cannot be sure that nothing undesirable will happen to it. Thus, I am simply reducing the risks. However, if the error on this linear guideway is up to 10 microns, the machine will likely meet the accuracy standard corresponding to Class A, perhaps even C. The C standard is the highest of the 5 established by GOST. When the repair is complete, I will more closely examine the established standards and determine which standard the machine will meet. This mirror support that I made specifically for this project will allow creating 4 reference surfaces on each of the guideway strips. Let's call them A1, A2, B1, B2, C1, C2, D1, D2. These 4 pairs of reference surfaces will be located in 2 planes, 1 meter apart. Precisely in the 2 planes where the right and left strips of the prism of this 3-meter prismatic linear guideway should be located. We will call them the alpha plane and the beta plane. First, I create the initial pair of reference surfaces, B1, B2, and C1, C2, located to the right and left of the center of the guideway. These reference surfaces will be positioned, B1 and C1 in the alpha plane, and B2 and C2 in the beta plane. Thank you to my viewers for their support on Patreon. I coat the prismatic feet of the mirror stand with paint and make imprints in these places. From the first imprint of the stand prisms, I got quite uneven contact traces on the worn surface of the guideway. I need to scrape these areas until I get a satisfactory paint imprint on their surface. This work requires an approach, as it is often just difficult to find even a slightly convenient position. Therefore, I assembled support structures around the guideway, similar to construction scaffolds. Scraping is already inconvenient, but otherwise, without supporting structures it would be extremely inconvenient. It is not about at least 25 spots per square inch, but the contact between the stand prisms and the guideway strips should be wide enough, distributed evenly across the area. I also prepared this block myself. The video is on the channel. Here is the link. I do everything smoothly, even a small blow will damage the precise surface. At this stage of work, this contact is quite sufficient. The first two pairs of reference surfaces have already been created. Now it's time to set up the autocollimator and attach the autocollimator mirror to its stand. At this point, 4 small sectors have been created, B1, B2, C1, and C2. They are segments of 2 imaginary planes, alpha and beta. The planes that are likely to become the restored surfaces of this prismatic linear guideway in the future. Thus, the segments on the guideway surfaces B1, B2, C1, and C2, which I just created, are now my zero level for the alpha and beta planes in space. That is, B1 and C1 are on the alpha plane and are the zero level for this plane, while B2 and C2 are on the beta plane and are the zero level for the beta plane. I still need to create the support sectors at the ends of the guideway, which I designated as A1, A2, and D1, D2. Currently, the B and C sectors are parts of 2 imaginary ideal planes, the alpha plane and the beta plane, as they are aligned with them by fitting to the meter-long stand, which is the carrier of the 2 planes at a 90-degree angle. The A and D sectors, due to the wear of the guideway, are outside the alpha and beta planes. Now I need to determine, using the autocollimator, the linear distance by which the A1, A2, and D1, D2 sectors are removed from the currently imaginary alpha and beta planes. To do this, I need to perform the following actions. I set the mirror on the stand on the B and C sectors. I center the autocollimator crosshairs on the autocollimator scale. Then I reposition the mirror on the stand on the A and B sectors. The B sectors are on the imaginary alpha and beta planes. And the deviation of the cross on the autocollimator scale will show us how far the A1 and A2 sectors are removed from the imaginary alpha and beta planes. It's difficult for me to take these shots, there are no additional devices, sorry for the awkwardness. After converting the angular deviation to linear size, I got the values, A1, 0.06 mm and A2, 0.1 mm. I can easily check if I made a mistake. I insert corresponding feeler gauges in the B1 and B2 sectors. If everything is correct, the inserted feeler gauges will compensate for the angular deviation for the mirror, and the crosshair will return to the center of the scale. I check. The crosshair has taken the central position relative to the autocollimator scale. Thus, I already know the deviation of the A1 and A2 sectors. I place the mirror again on the B and C sectors just to verify if the instrument readings are repeated. Excellent, the cross is back in the center of the scale. Similarly, I determine the deviation of the D1 and D2 sectors. Here D1 is 0.08 mm, and D2 is 0.4 mm. Others work here besides me, so it's noisy. The cross came to the center again, since I placed probes of the appropriate size at points C1 and C2. Once again I additionally check the repeatability of my measurements. If everything is correct, the cross will again be in the center of the scale. So, the first step in this repair has already been completed. Of course, we should not forget that in this case the linear dimensions of the measurements are related to the vertical vector. A coefficient must be applied in the perpendicular to the plane. I consider it unnecessary to concentrate this fairly large and complex work in one video, so for today, that's enough. to be continued. There will be much more interesting content in this project. First, I need to determine how the positions, or more precisely the intersection, of the imaginary alpha and beta planes correlate with the horizon, and evaluate whether it is worth aligning the position of the linear guideway with the horizon in this project. I will check how the 90-degree angle of this guideway is maintained in relation to vertical and transverse feeds. I might find it appropriate to adjust the position of the alpha or beta planes, aligning the B1, B2, C1, and C2 sectors. Once I finally determine the position of the imaginary alpha and beta planes, I will create the A1 and A2 sectors, then D1 and D2 sectors using the scraper. On the worn guideway surface, there will be 4 paired segments, revealing the face of the new, already restored guideway. I am finishing the manufacture of a reference straightedge type bridge for the final stage of this work. The bridge straightedge will be very precise, with a surface accuracy up to 1 micron. It will be rigid enough and lightweight. All that remains is to connect these segments, A1, B1, C1, and D1 in the alpha plane, and A2, B2, C2, and D2 in the beta plane. And this no longer requires more than just scraping cast iron by following the paint marks. It's not such a complicated task. Just mechanical work. As a result, I will get 2 continuous, flat, and straight lines that will form the new, correct guideway. I hope that after some time, this machine will be able to perform its work decently. Let me know what you think of this method. I have not come across information about it, I developed it independently, but I believe I am not the first to use it. As the autocollimator itself dictates such an algorithm of actions, interesting circumstances that may arise in the course of work or communication with viewers. I will probably reflect in the description of the video and in the pinned comment, so check the description and the comment just in case. Goodbye.